Hey, it's Mr. Donahue again. This time we are going to take a look at how to name alkenes and alkynes. Okay, so again, we have a systematic approach to this. All right, so first thing you're going to do is find the longest continuous chain of carbons, and this is going to be your base name. Then you're going to number the carbons so that if there's a substituent group or a functional group, it is given the lowest possible number. So you're going to be trying to number them so that where that double bond or triple bond is ends up with the lowest number. Then in your name, you give the location of each substituent group. And then if you have multiple substituents, you use the same kind of, di, tri, tetra, penta, etc. for 2, 3, 4, 5, so on and so forth. And then you list them alphabetically. Okay? So alkenes. Alkenes, again, the name's going to follow the pattern of whatever the base is, followed by the suffix. So in this case, the suffix is "ene", just like in the name alkene. And the base is going to tell you how many carbons you got, right? So you're going to see things like propene, where you're going to have 3 carbons with a double bond somewhere in there. You need a number to describe where the double bond is if it's ambiguous. And you'll see what I mean by that. Sometimes there's only one possible place where that double bond can be, and then you don't really need a number. All right, so let's try naming this. All right, first thing, find the longest chain of carbons, and this one is pretty straightforward. We got a 4-carbon chain. So we're going to now number it to give the smallest number to the double bond. So if we number it left to right, we got 1, 2, 3, 4. And if we go right to left, we get 1, 2, 3, and 4. So it's going to be after the first carbon, which is going to be the lowest possible number that we can get on it. So we're going to number it left to right. So then name and give the location. How do I say 4 carbons? Bute. How do I say there's a double bond? Ene. And how do I say where this double bond is? Well, it's after the first carbon, so it's going to be 1-butene. That's it. That's all you got to do. All right, so again, find the longest chain. This one's really simple. There's only 2 carbons, so I know that the base is going to be eth, double bond, so that tells me that the suffix is going to be ene. And now the question is, do I need to give the location? Well, no, because there's only one place where that double bond can be in ethenes between the 2 carbons. So I don't need a number. It's just ethene. All right, let's label these ones and name this. Well, all right, well, I got 1 carbon here, so let me number them. I got 1, 2, 3, 4, 5, 6, or going right to left, 1, 2, 3, 4, 5, and 6. So in this case, again, going left to right will give me the smallest number for saying where that double bond is. So how do I say it? I have 6 carbons. I use the base hex and double bond, so ene. And now I got to say, where is it? Where is it? It's after that first carbon. So it's going to be 1-hexene, and that is the name of that molecule. All right, ooh, look at this one. We got 2 double bonds going on. Interesting, interesting. All right, well, same process. First step is find the longest chain. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's going to be 4 a bunch of different ways. So I'm going to use the way that includes the double bond. So 1, 2, 3, 4. And now I got to figure out, well, which way am I going to number it? And hopefully you can tell by looking at it that it doesn't matter if you go left to right or right to left. This is a symmetrical molecule. So I'm just going to start naming it. All right, well, I got 4 carbon chain, so base is bute. And I got a double bond, so it's going to be ene. And hey, I'm going to show you something cool. Because this one has 2 double bonds, you want to say di for 2. But where do you put that di? You just put butadiene. And that's how you say that there's 2 double bonds. So this is butadiene. And now I got to say where those things are. Well, they're on the first, after the first, and after the 3rd carbon, right? So it can be 1, 3, butadiene. And I also have these dingly-danglies. Now, what are those dingly-danglies? Well, they are methyl groups. So how do I say I have 2 methyls? I got dimethyl. And where are they? They are on the 2nd and the 3rd carbon. So it'll be 2, 3. Here, let me rewrite it. 2, 3, dimethyl. 1, 3, butadiene. And that's the name of this molecule. Same process, same system. So you're just doing that. All right, so what if I had a name and I wanted the structure? 3-octene. Well, let me break it down. Oct tells me that there's 8 carbons. So I'm going to draw 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to make bonds with all of them right there. And the ene is telling me that there's a double bond somewhere, and it is on after the third carbon. So 1, 2, 3. So after this carbon, there's a double bond. So now I need to just complete the octets for my carbon. So this carbon is going to have 3 bonds to hydrogens. This one only 2. This one's only going to have 1 because there's a double bond there. So there's already 2 bonds there. Same thing with this carbon. And then this one's going to have 2, 2, 2, and 3. And I'm lazy. There's H's on all those lines, but I'm not going to draw them. Okay? All right, so alkynes, it's the same thing, except slightly different. All right, so the base suffix thing is still going to apply. You still say how many carbons do you have, and this time the suffix is different. You use "-ine" because it's an alkyne. So you'll see something like propine, where you have 3 carbons and there's a triple bond somewhere in there because of the "-ine." So you need a number to describe where the triple bond is if it's ambiguous. Again, sometimes it can only be in one spot, so you don't really need a number. So let's look at this one. Find the longest chain. I got a straight chain 1, 2, 3, 4, 5, 6 carbons. How do I say I have 6 carbons? Hex. How do I say I have a triple bond? Ine. So right now I have hexine, but now I got to figure out, well, which way am I numbering this? Well, if I go left to right, I get 1, 2, 3, 4, 5, 6. Or if I go right to left, 1, 2, 3. And if you take a look, it doesn't matter. Either way, you get 3. So it's going to be 3 hexine. It doesn't really matter if you go left to right or right to left. It's right in the middle. So you end up with the same thing. All right, what about this little critter? All right, I got a 3 carbon chain, so I'm going to use prop as my base. And that's not how you write an R. So prop, how do I say there's a triple bond? Ine. And now do I have to say where it is? No. But Mr. Donahue, couldn't that triple bond be right here instead? Well, if it was, what would happen is you'd get a molecule that looks like this, which is the same thing as this. It's just turned around. It's just you flipped it around. You're looking at it from the other side. So it's really the same thing, so you don't need a number. It's just propine. Okay, so let's take a look at this one. All right, well, I know there's going to be a carbon here, there's a carbon here, and there's a carbon there, and there's a triple bond in between them right here. And then I finish the octets for my carbon. Sometimes, especially with an example like this, it's easier when you draw it out with the carbons and get the structural formula. Okay, well, this looks a lot like what I had in the previous problem. So I have 3 carbons, so it's prop. I got a triple bond, ine, and I don't need a number because it can only be in one place. If it wasn't here, it'd be here, and it's really just the same thing, just turned around. You're looking at it from the other side. So what if they told me I had 2 hexine? Well, break it down. Hex tells me that I have 6 carbons. So 1, 2, 3, 4, 5, 6. And bonding all those carbons. And that 2 is telling me that after the second carbon, so 1, 2, after the second carbon, I have a triple bond. All right, and the best way to really draw this would probably be like this. That triple bond is going to make a linear shape in this region because of how it's bonded. So it would look like this. So I'm going to erase this a little bit, get rid of that. And then I complete the octets. This carbon will get 3 hydrogens. This carbon is full. It's got 1 bond here and then 3 there. This carbon is also full. And then this carbon gets 2, 2, and 3 hydrogens. And that is how you go from the name to the structure. Cool. And that's alkenes and alkynes. Hope you found that helpful. I'll see you in class. Bring questions. Bonus round. All right. Try to name this and then try to draw this. I'm gonna draw something real quick. Yeah. No, that's not. There we go. That's what I'm gonna draw. So what is this? All right. Pause it. Try these things, and when you're done, unpause it. Okay. So let's name this. Well, I got a double bond here, so I know it's going to end in ene. And now I got to find the longest possible carbon chain. I got 1, 2, 3, 4, 5, 6 is my longest. So it's going to be hexene. And that double bond is after the first carbon. So it's going to be 1 hexene. And I also have these dingly danglies, which are going to be methyl groups. So again, I have 2 methyl groups. So how do I say I have 2 methyl groups? Well, I'm going to say dimethyl. And I got to say where they are. They are on the 4th and the 5th carbon. So it'll be 4, 5, dimethyl, 1-hexene. And that's it. All right, draw this. 3-methyl, 2-octyne. All right, so octyne is going to tell me I have 8 carbons. So 1, 2, 3, 4, 5, 6, 7, 8. The 2 is telling me where the triple bond is. So it's after that 2nd carbon. So boom. And 3-methyl is telling me on that 3rd carbon, there's a methyl group. Haha. And this should be yelling at you because, hey, wait a minute, that can't happen. This is not possible. Why? Because this carbon right here is doing this. It's making a triple bond and it's bonding with another carbon, and then it goes on and on for the chain, and it's saying there's a methyl group on that. That has 5 bonds. That's not possible. Cool. Should have picked a better example. Anyway, I'll see you in class, kids.